What do you notice? What do you wonder? Mario! What do you notice? Just something. Anything in particular? Come on, Mario. You can do this. One thing?
Did you have a twin? Did you have Mr. Trump?
My wife. Same. So let's take the same shape. So they all share the same shape. They're probably all the same type of polynomial. Anybody tell me what type of polynomial that might be? Done a few of these already.
It's like a third degree.
It's a third degree polynomial. So third degree polynomials are cubic. So they're all cubic polynomials. Okay. What else do they got in common? So they all have the same shape, but they're not all they're not exactly the same. That would be boring. What's different about them?
They have
Different intercepts, okay? They don't all have different intercepts, but like the first one and the second one have two intercepts that are the same. So first two share two x-intercepts, so let's be precise. Intercepts. Okay. Anything else? Wonder why they have different intercepts? Okay.
Do we have to type that somewhere?
That's up to you. Okay. How do you match equations and the intercepts? Anybody have ideas? Yes. Go ahead. I'm listening. You mean zoom in? Okay. So, let's talk about that.
I noticed that the x plus 5 and the x plus 1, like, if you make it negative values, that's the intercepts. And then the x minus 3, if you make it a positive value, that's another x-intercept.
That's exactly right. Okay. So, we're going to formally define this by stating you have, when I have three things multiplied together, they have names. That's what's 2 times 3 times 5. What would be the relationship between 2, 3, and 5? They are all what? They're prime numbers. What else? So say it was 2, 4, and 5. 4 is no longer prime. So 2 times 4 times 5. Who said all odds? They're factors. Okay. So to find your intercept, you take any individual factor. So x plus 5. Oopsies. And you set it equal to 0 because we're trying to find out where the f of x value is equal to 0. And then in order to solve that, I just subtract 5 from both sides. And that's why I get x equals negative 5. And then I do that for every single one. So that's why it's the opposite. So if you see a plus, I have a negative x-intercept. If you see a minus, you get a positive x-intercept. That's it. Okay. So that's one of the new things we're going to talk about. Once you've done that, scroll down the next page. We are going to find the actual x-intercepts. So there are 8 equations. So you need to find the x-intercepts. So question, when I have 3 unique factors like I do in number 1, how many answers should I get if I have 3 unique factors? 3. Okay. So when you have a unique factor, find them. Some of these are going to prove more difficult than others. And there's one I will be quite impressed if you can figure out without graphing it. Okay. So find your x-intercepts for 1 through 8. Work in pairs. You can share the load, but make sure you understand what the other person's doing. All right, go work.
All right, what's the answer?
Called a cubic trinomial. When you have 4, when you break a gallon down into 4 parts, what do you call each part? A chord. So this is actually called a quartic trinomial. So we have 4 different vectors. You can have 4 different answers. Go ahead, Edwin. What are the 4 different answers? Yes, sir. Can't hear you. A little louder. -4. -2. 1. Question so far? Pretty easy, right? Second one. Oh, another quartic. How can I tell it's quartic? Because I look at my exponents. 2 plus 2 is 4. Do I have 4 answers? Kinda. How many different answers do I have? 7. If I have quartic, I can't have more than 4. How many different answers do I have? I just got the 2 because I have 2 factors. So x equals -4, comma, -2. So let's type that into Desmos and see what it looks like. So just do x plus 4 times x plus 2. Type y equals, don't bother with the x equals 0. So I'm going to make a new Desmos somewhere. Desmos. So y equals x plus 4, close, open, x plus 2. Is that right? Or is it, was one negative, one positive? They're both positive? Okay. All right. So right now, what's this one called? I got a second degree. Do you remember the name of second degree equation? Sounds like quartic, but it's quadratic. So this is a quadratic equation. So let's go ahead and square stuff. So I square this one. It is no longer quadratic. Now it is. We just said, doesn't this look like the ones at the beginning of class? It's not what were the ones at the beginning of class. Cubic. So this is a cubic equation. Because, ready? This has an exponent of 2. If I don't see an exponent, the exponent is, ready, watch the magic, 2 plus 1 is 3. Okay? But that's not what they had. They had both of them squared. So this one squared 2. So originally it was an n, now it's a w, and nice and symmetric and all. Okay. So it's a quartic equation with 2 unique solutions. When it bounces off, that means I have a double or quadruple or an even power. So in this case, it's double. So double root at -4 and double root at -2. That's why it bounces off. That's what the square does. Okay. Because think about it. If everything is squared, can it ever be negative? And the only time it can be 0 is at -4 and -2. All right. -2, what does that do? So I'm not going to rewrite all these. I'm going to put the negative on the other one we just did and see what happens. Let's move this over here. So watch what the negative does. It takes an end, flips it. Okay. The official mathematical term is it reflects across the x-axis. Watch what the 2 does. Again, didn't change the intercepts, but it elongates it. In mathematical terms, we say stretches it. Okay, it's going to get to all of those y values twice as fast. All right. So it doesn't affect the zeros. It is a quartic. It's basically the same as this one up here, except all the signs are switched. So if I do a little Control A, Control C, come down here, Control V. Put a negative, put another negative. You're probably right. I could have probably typed in faster, but I'm doing things one-handed, so. I spell what? Quartic. Quartic equation. I'll even make it nice, cat blocky. Q-U-A-R-T, just like quart. I see. Quartic. Did phonetic spelling, yes. So anytime you have a Q sound, phonetic spelling is going to start with a C. Okay. All right, this one's a little harder. So 2x plus 8. So this is worth taking a moment to actually solve. Okay. 2x plus 8 equals 0. Subtract the 8, divide by 2.
Yes.
So that's going to give you -4. Okay. Next one's a little harder, but you don't have to do this on paper or in your head. You can do this in your head. Watch how you do this in your head. All right. So add the 3 and divide by 7. So the negative becomes positive and divide by 7. So it's just 3/7. Okay. Now, could we have solved this graphically? Yes, you can solve just about anything graphically, but here's why it's not a good idea. All right. So let's go back to Desmos and let's put this one in. So I'm going to turn this off, turn this on. So y equals 2x plus 8, close open, 3x minus 7, close open, and what was the last one? X minus 10. All right.
Wait, wasn't 7x minus 3?
Yes, thank you. I transposed them, thank you. So 7x minus 3. And then I want to make sure I can see this one. So here are my intercepts. There's -4, there's positive 10, and that, believe it or not, is 3/7. Okay? So let's go to the line below it. Do 3 divided by 7. 0.42857.42. Oh! Any fraction can be rewritten as a repeating decimal. If it doesn't, 42857.1 with a line over it. So 6-digit repeating decimal. And that's what sevenths will give you. This will not be precise enough. So what that's doing is rounding off the nearest 100 thousandths. Okay. So the way you would write it would be 0.4285714 with a bar over it. Eek.
Y'all just put the bar fast.
Okay. So that's how you write 3/7 as a repeating decimal. All right. Let's turn that off and go back here. All right. Let's skip 6. We'll do that one last. All right. And we got this one? You got it, Ben? No? Okay. Danica, you got this one? Joseph? Nobody has 7? Well, let's figure out. Is it quartic again? Yeah, I got 4. So 3 minus x, well, still, what do I subtract 3 from to get 0? So that's 3. 1. I can get decimal answers? Sure you can. 0.75. I'm not going to be picky about that. So I'm good so far? I got a boo-boo up here with my boo-boo.
Isn't it negative?
It's negative 0.75. Okay. All right, and let's talk about this one. This one's so easy. It's one of those things that's like too easy. You're like, I don't understand why. If I set that equal to 0, what does x equal? 0. So one of your answers is 0. Okay. It will cross at the origin. So if you do not have any numbers being added or subtracted and all you see is a variable, 0 is one of your solutions. Okay. All right, this last one. A little harder. What kind of equation is this last one? I see a 2 and I see a 1, so it's. I am confused. I see 2 factors. How could I ever come up with a third answer? Let's try it out. Take our time with this. Ready? Here we go. X squared minus 4 equals 0. X squared minus 4 equals 0. Okay. Add 4 to both sides. So x, I'm going to do this way over here. Here we go. X squared equals 4. Equals 4. And now here is the tricky part. I need to undo a squared. How do you undo a squared? Square root. Okay, not too bad. And that's not the tricky part. Most of you can figure out that part. The next part is the tricky part. I have a second degree polynomial, which means how many solutions should I have? When I take the square root of 4, what do I get? Yeah, that's 1. Where's my other answer going to come from?
X plus 9.
Okay, well, that's 2. We have a third one. So let's come back here. And instead of just x, because if I square -2, I can also get 4, yes? So the way we show this is with this little symbol right absolute value of x. Okay. So what does absolute value mean?
How far away from 0?
Awesome. One more time.
How far away from 0?
So on the number line, how many directions do we have? 2. So that's why we have 2 answers. So we go 2 to the right and 2 to the left. So what I'm going to have here are 2 answers. X equals -2, comma +2, and I still have the -9. The other way you can also write this is x equals, if you look at that third row down right in the middle, you see this plus on top of a minus sign. You can use that one too. Okay, so plus or minus 2, comma 9. I don't care which way you write it, as long as I can clearly see that there are 3 answers. Question so far?
Yes.
All right, let's do number 6 graphically. So graph y equals, so don't put the equal 0, x squared plus 3x minus 4. Okay, so just graph it. Y equals x squared minus 3x minus 4. Y equals x squared, so turn off this one. Y equals x squared plus 3x minus 4. And then I can clearly see I have 2 answers. Okay? So now we know what the intercepts are. I want you to rewrite this equation in factored form so it looks like these ones up here. Okay? So right below it, rewrite it in factored form. So let's first put down, we have x equals -4, comma 1. And now I have 3 solutions. So what type of equation am I looking for? Cubic. So write a cubic equation that has -5, +4, and 0. And if you get that one done, I want a 4th degree, a quartic that has -5, 4, and 0. Okay? Take a couple minutes to try to do those on your own. What happened? Okay. So just square any one of the 3 factors, and that will give you a quartic. Okay. So when it's open-ended like that, you could have chosen any one of the 3. Notice every time you have a squared, what happens? Okay. Once it hits the axis, it bounces. Okay. So in this case, it dips down. If it was the other way up, it would bounce off. So it's going to bounce off the axis. All right, those cards that I gave you. Here's what you're going to do. You match equations to graphs. It's that simple. Okay, it should take you somewhere between 5 and 10 minutes. When you're done them all, either call me over or I'm going to give all the answers when everybody's done.